Okay, we're doing related rates notes. So, Parker's pumping air into a spherical balloon at a rate of 6 centimeters cubed per minute. What is the rate of change of the radius when the balloon has a radius of 12 centimeters? So we're going back to a little bit of derivatives because I wanted to do these word problems and then do optimization word problems. So we do word problems back to back but separate weeks. Okay, so we need to have a formula that we use. So it's usually a volume formula or an area formula or surface area formula or Pythagorean Theorem or trig formula. And we're going to derive it because it says what is the rate of change. And the moment there's a rate of change or something per something like centimeters per minute, we know that's a derivative because rate of change is derivative. Now we know centimeters per minute is a volume, and we know it's a volume of a spherical balloon. So we need the volume of a sphere. And now on any test, you'll be given the actual formulas. So on an AP exam or anything like that, you'd be given the formulas. On the assignment sheet, the top of the assignment has all the formulas that you could possibly use. So the formula we're going to use is volume of a sphere, which is V equals, it's not supposed to be a fancy V, that's just an oops, 4 over 3 pi r cubed. Okay? And we're going to write down what we have. Well, we know we have the derivative of the volume because it's volume with respect to time. So we're going to write it as dV over dt. So this is, remember how we did implicit differentiation when we took the derivative of a y? We always did dy over dx. Okay? And then when we did the derivative of an x, it was dx over dx. We didn't have to write it. Well, all of these are with respect to time. So when you take the derivative of any variable, you have to follow behind with that variable, d that variable over dt. So we know that this is the derivative of volume with respect to time because centimeters cubed is the volume and minutes is the time. So that's a giveaway that it's volume because it's centimeters cubed per time. So the derivative of a volume is, and it's pumping air in, so it's positive 6. If it was deflating air out, you'd use negative 6. So it's going to be 6 centimeters cubed per minute. What is the rate of change of the radius? That's what they want. So we want dr over dt. That's what we're asking to find when the radius is 12 centimeters. So the radius is something that can change, right, on this because the balloon can get bigger and bigger radius or smaller and have a smaller radius depending on if it's inflating or deflating. So we write down our knowns, and our knowns are dv over dt and r, and we're looking for dr over dt. And we always start off with a formula and then find the derivative of that formula using implicit from way back when. All right. So if we take the derivative of this formula, we take the derivative of v, which is 1. And then we'd follow behind with it, derivative with respect to time, so dv over dt. So the derivative of v is dv over dt equals 4 pi is just a number. So it's like 4 pi r cubed. So if I had 4 pi x cubed, you'd take the 3, drop it in front, and just do power rule. So you do 3, 4 over 3 pi, and then you'd go r, drop it down by 1, squared. And that would be it if it was an x. But we took the derivative of r, so we have to follow behind with dr over dt. Now, once we took the derivative of that formula, we can fill in our knowns. So we know that dv over dt is 6 centimeters cubed per minute. And I always write as a fraction, so my units will be able to drop off like we do in physics. 3 and 3 cancels. So it equals 4 pi r squared. R is 12 centimeters squared. And then dr dt we don't know. So then we go and do math. So we're going to get 6 centimeters cubed over minute equals 4 pi. And then 12 centimeters squared is 144 centimeters squared times dr over dt. So now I have 6 centimeters cubed over minutes equals 4 times 144 is 576 pi centimeters squared times dr dt. And then how do I get dr dt by itself? I'm going to divide by 576 pi centimeters squared. So I'm going to get 6 centimeters cubed. Oh my goodness, that's a terrible 3. I'm going to retry that. 6 centimeters cubed over minutes divided by, and I'm going to write sideways because it's a fraction, so our units will be able to cancel, 576 pi centimeters squared equals dr over dt. Then I can flip that and multiply. So I get 6 centimeters cubed over minutes times 1 over 576 pi centimeters squared equals dr dt. Then just like in physics, we cancel off. So I'm going to get centimeter squared, cancels off 2 of these. And then I'm going to get 6 divided by 576, which is 1 over 96. So if I reduce the fraction, 6 divided by 576, I get 1 over 96. The pi is still there, and my units that are left over are centimeters per minute. And we know we're right if it matches our variables. Radius is in centimeters per time, which is in minutes, so we know we're good. So the radius is increasing at 1 over 96 pi centimeters per minute, and you could turn it into a decimal as well. If it was an AP question, you'd have to round it to 3 decimals because that's what you have to do. Okay, so that was a volume of a sphere. Example 2, Chloe and Mrs. Lepp are filling an ice cream cone. Now the ice cream cone is going to be slightly large, but that's why Chloe's there to help me. Okay, the cone is 12 centimeters tall and has a radius of 4 centimeters. So that's not changing. That is actually what the cone is. It doesn't change if I fill it up with ice cream or not, right? The cone is 12 by 40. So it has a height of 12 centimeters and a radius of 4 centimeters. That is not changing. So I'm going to box those because those are not changing. If the ice cream fills the cone evenly at a rate, so we're filling a cone and it's centimeters per second, so it's volume of a cone. So dV over dt, and it's filling it, so it's positive, 1.5 centimeters cubed over seconds. So it's filling it with a rate, and centimeters cubed per second gives away its volume per second because centimeters cubed is volume and second is time. So dV over dt. What is the rate of change of the height? They want dH over dt. When it is a height of 5 centimeters. So that's when the ice cream is at a height of 5 centimeters, not the cone. That stays the same. Okay. My formula for volume of a cone volume of a cone is 1 over 3 pi r squared h. Now this is a problem because I'd have to do product rule if I differentiate this. I have an r squared, I have an h. So what I need to do is I need to get rid of the r squared because I don't have a dr dt to fill in for it. So the r squared has to go away. And that comes from the fact that this is a cone and this is not changing. So I am going to make a ratio out of this non-changing cone ratio. So it is going to be height over radius. So I'm going to go height over radius, and then I have to put the height, which is 12, over the radius, which is 4. Now what I want to do is I want to get rid of the r. So if I solve this, cross multiply it, and solve for r, I can replace it with its ratio of h. So I'm going to go 12r, I just cross multiply, equals 4h. 12r's equal 4h's. And then I need to get r by itself, so I'm going to divide by 12. So r is the same as having 1/3 h. Okay, so now before I find the derivative of this formula, which I don't want to do right now because I'd have to use product rule, I'm going to input for the r's 1/3 h. And the reason why I want to get rid of the r's is I don't have a dr dt, and I don't have a radius to fill in for it. They want dh dt, so I need to get rid of the r's. If they wanted dr dt, I'd have to get rid of the h's, and I'd solve for h in this step. So r is 1/3 h, so I'm going to fill that in for the r right here. Choose a different color. I'm going to fill it in for this r. So I'm going to get v equals 1/3 pi 1/3 h is what r is, and I have to square it, times h. So I'm going to get v equals 1/3 pi, oh my goodness, I need a new stylus because this one's not working. 1/3 pi 1/9 h squared, because 1/3 h squared is 1/9 h squared, times h, which gets me, if I put it all together, v equals 1/9 times 1/3, I can put at the front, 1/27 pi h cubed. And now the formula has no r's in it, so I can find the derivative of it. And I don't have to use product rule. So the derivative of this, the derivative of v is dv over dt. And it equals, take the 3, drop it in front, 1/27 pi h squared times dh dt. And then that gets me dv over dt equals 1/9 pi h squared dh over dt. And now I can plug in my stuff that I know. So I know that I have dv over dt, which is 1.5 centimeters cubed per second. Equals 1/9 pi h squared. So h is going to be 5. I use this h because this is the changing h. So 5 of the ice cream. 5 centimeters squared. And then I'm looking for dh dt. Hand down. Okay. And then I'm just going to move ahead to a separate sheet so I don't have to squish. So right now I have 1.5 centimeters cubed per second equals, and I'm just rewriting this, 1/9 pi 5 centimeters squared dh dt. So now I'm going to do that 5 centimeters squared part. So I'm going to have 1.5 centimeters cubed per second equals 1 over 9 pi. 5 centimeters squared is 25 centimeters squared dh dt. So I get 1.5 centimeters cubed per second. And now I can put the 1/9 and the 25 together. So I get 25 over 9, the pi's on the top, centimeters squared times dh dt. And to get dh dt by itself, I need to divide by 25 pi 9 over 9 centimeters squared. So I'm going to get 1.5 centimeters cubed over seconds divided by 25 pi over 9 centimeters squared equals dh dt, dh over dt. Then I can flip that by multiplying. So I get 1.5, oops, touch down again. So I'm going to get 1.5 centimeters cubed per second times 9 over 25 pi centimeters squared. That's a centimeters, doesn't look like it, so I'm going to redo it. Centimeters squared equals dh over dt. And then I can cancel. So centimeters squared cancels off 2 of those. And then I can go 1.5 times 9, which is 27. 1.5 times 9 divided by 25 in my calculator. 1.5 times 9 divided by 25 gets me 27 over 50. The pi is still on the bottom. Centimeters per second equals dh dt. Now it's positive, so my height is changing with respect to time. It's increasing 27 over 50 pi. Now you could turn that into a decimal. Centimeters per second, it might mean more. Now it should be positive because the height of the ice cream is increasing because we're filling that cone up. All right, so those are my 2 volume types questions. If you have volume of a cone, you're either going to have to get rid of the R or you're going to have to get rid of the H in the formula before you derive it, using that, the original R and H's that don't change. Now, we have Ben has a ladder that is 8 meters long and leans against his home. So I'm going to draw his ladder. Here's his ladder. His ladder, I'm going to label as L, is 8 meters long. What's the change in ladder with respect to time height? Does a ladder change in height as it's against a building? No. So if it's a ladder or something that doesn't change in height ever, it stays the same, then you would say dl over dt equals 0 meters per second. And I know that because it's in the question, meters per second. So I know L is 8 meters, and I know, L is 8 meters, and it's a ladder, so it's not going to change. Okay, if the bottom of Ben's ladder slides away from the building horizontally at a rate of 0.75 meters per second, so that's going to be the bottom sliding away, and it's with a rate. So I'm going to say bottom. So I'm going to go dB over dt equals 0.75 meters per second. And it's positive because it's sliding away. The base is sliding away. Now it says, how fast is the ladder sliding down the wall? So they want, I'm going to say height. They want dH over dt. This is the height over here. They want dH over dt. when the top of the ladder is 5 meters from the ground. So we know that the height of the ladder from the ground, this h, equals 5 meters. Okay, so we know L, we know H, we don't know B. How can we find B? Well, it's a 90-degree triangle. We can use Pythagorean Theorem. So technically we have L squared equals H squared plus B squared, right? We can't do this with derivatives. We can only do it with side lengths. So we want to solve for B. So we're going to do B squared equals L squared, which is 8 meters squared, minus H squared, 5 meters squared. And so we're going to get B squared equals 64 meters squared minus 25 meters squared. And so we get B squared equals 39 meters squared, square root. B equals square root of 39, and the square root of meters squared is meters. Okay? Now, what formula can we use here? Well, we can use, the other ones are volumes. This one is Pythagorean Theorem. So we need an original formula so that we can do the derivative of it, right? So our original formula is going to be L squared equals H squared plus B squared. Now we can do the derivative of that. So L squared is 2L. Then I have to follow behind with dl over dt, because with respect to time. H squared is 2h with times dh over dt, so with respect to time. Plus b squared is 2b times db over dt. Okay? Now, 2 times the length, which is 8 meters, times the length with respect to time, which it doesn't change. It's the length of this ladder. With respect to time, the ladder will move down and up, but the length of the ladder doesn't change. So it's 0 meters per second equals 2 times height, which is 5 meters, times dh over dt, which we don't know. Or do we? Nope, that's what we're looking for. Plus 2 times the base, which we found was root 39 meters, times the rate, which is 0.75 meters per second. Now, 2 times 8 times 0 is 0. So I'm going to get 0 equals 10 meters dh over dt plus 2 times 0.75 is negative, and it was, sorry, the bottom of the ladder slides away from the wall horizontally at a rate of 1.7. So, yeah, we're going to get 2 times 0.75, which is 1.5, root 39 meters. Per second. Can't forget that. Okay, so I need to move this over to the other side by subtracting it. So I'm going to get negative 1.5 root 39 meters per second equals 10 meters dh dt. And then I just need to divide that 10 meters over. So I'm going to get dh over dt equals negative 1.5 root 39 divided by 10. And then I'm going to get meters per second, which is actually, because that doesn't make any sense, it's a really weird number, so I'm going to turn it into decimal, 0.937 meters per second. Now what does the negative 0.937 mean? At dH/dt, that height of this ladder right here, well, as it's sliding away, so say this is my wall, as the ladder is sliding away this way, so it's sliding this way, right? It's going to go from being up here. If it's sliding that way, it's going to end up going downwards, right? If it's sliding away. So this change in height is actually going down, and that's what the negative means. So it says, how fast is the ladder sliding down the wall? Down the home. Down that home. It's sliding 0.937 meters per second down. We don't need to put the negative sign if we put down, it's a vector. Down the home. Okay. Example 4. I did the worked out solutions for it. It's just there for if you want to look at some other type of related rate, if you're interested, if you're intrigued, if this is like something you find fun, maybe Jacob, look at the worked out solutions to example 4, but I didn't give you any questions like that, okay? If during the assignment you're stuck or you're freaking out, ask for help, okay? After you've watched these videos, ask for help, and I can go on to Google Meets, Hangouts, and we can, Hangout Meets, whatever it's called, and we can discuss where you're stuck, or I can give you hints, or I can help you out, okay? So don't freak out if you get stuck, all right? And only do example 4 if you're really intrigued into this, okay?